we do model kinds and model hierarchy. And we are at the exercise. So I'm using a cursor here. You can also use Visual Studio Code. Barebone works as well. So we go to, let's close that. Asset structure, exercise 9, set model kinds. Let's look at that. What is it? Okay, so straightforward. It uses, it opens the stage in the working directory, this large building F, this guy, gets the default prim, and then we have to set the model kind, and then it does a save. So let's execute it. Well, let's first add this code. Whoop. So what does it do? We got the default prim. We use the model API and the set kind method. And what kind? It's a component. Let's do another terminal. As always, we have to activate our Python environment. Oh no. It was already activated, no? And let's run the script. We are on Windows, copy, right? Oops. No, it runs. Maybe slow, but no. So. And now let's open. It says we should open the model, right? I've already. Let's do that again. File, open. No. What's it? Here is the rule. This is structure. Which one is it? 9, right? The large building. Open. World. See, yeah, here in metadata, you see kind component. That's what we just did. We could. Shall we try and change it to something else? Kind tokens like assembly. Let's try if that works. Oh, I think I have to reload it. Reopen stage. Oh yes, it's an assembly. See? Now let's change it back to component because we want to continue the course. Set component, loading it again, reopen stage. This is the USD view with a standard distribution, actually. Let's check out the world. It's component again. Yes.
So if I were to define my own kinds, they could inherit, like on a object-oriented way, from any of the existing kinds, and then I just
they're just these kinds in this API.
Yeah, but I'm pretty sure wasn't there something about registering your own kinds.
Oh, well, yeah. I haven't done that before. If you're aware of that, anybody deriving kinds?
Because
I haven't
I
used
think
it. No.
it could help if you want to have more abstraction layers to have different filters, right?
Probably. Yeah, I don't know if then the thing is, any other software won't be aware of your structuring, and so I would be careful with that.
I think in the video from Monday or Tuesday where DV was talking about this, he was going into this.
And
the
what
dangers.
was his conclusion? Yeah.
Yeah, you can do it, and it helps, but it's dangerous because you leave the normal.
Exactly what you said.
Is it schemas? Is it schemas? Yeah, you leave the normal definitions.
Yeah. Okay, so that worked. So we have seen the component. Now let's go to assemblies. Next time we create a new assembly asset with called city block A that will reference our model multiple times. Yeah, that should work. We set the model kind of new asset to assembly. Okay, so let's open that. Exercise 10. Exercise 10. Create assembly. So what happens here? We create a new layer, which is basically a new USD file in USDA. That's the ASCII format, so you can actually read it, which also makes sense for assemblies because the heavy elements are the components, basically. So we have a nice small thing to read. Creates it, opens the stage with the asset layer. Yeah, interesting. And defines the world as a transform prim, right? Sets the default prim to world prim. Then we do all stuff. That's also something they use Y up as an axis. In manufacturing, a lot of systems use Z up, so you can determine this with that. Also, the stage meters per unit. So we have centimeters, which is basically 0.01. And it saves it. Yep, sounds good. So first, let's set the model kind to assembly. Yes, that's that kind of part. That's what we also did here. We set the world is an assembly. Makes sense. So next, we will populate the asset by referencing the component asset. So we do an array, so a for loop from 1 to 7. We append a child, which has this number with 0 to. That means you add a 0 if it's just one digit. Then we have a transformation defined. And we add a reference to our building, right? And we position building. So there is a position building function. Let's see what, well, that's maybe just copy and paste it to our source and then look what happens actually. Position building, it says position building uses our reference target prim and says X, so 1 to 7. So there should be some, see, there is a position building built for us. It gets the index, so 1 to 7, right? It creates a transformation on the prim, and it offsets the building. So, what happens? If the index is larger than 3, it also adds a little Z offset and rotates the building. And in any case, it says the translation. to some, in a row kind of form with a Z offset, and it rotates it as well. So yeah, looks good. Let's see what happens. And it saves it. Any questions for that? Pretty straightforward. So let's run it. Okay. It created our city block. Let's look inside. This is also interesting. City block A is called USD. You could have expected it to be named USDA because it's ASCII, right? But USD can be ASCII and binary. So.
So when we want to be precise, we say USDC for like really compressed. USDZ if it's zipped, which is what Thomas is working with on the Apple, where everything is in there. And USDA is the ASCII, and USD can be both.
Yes.
Okay.
Exactly. That's maybe why they created this in this form. They created the layer first. Well, yeah. See, you could also like use the USD stage API to create a new USD file, like create new, and give it a name, but it determines then the format from the name. So and this way you can basically tell it's a USD, but the format is USDA. That's the more, yeah.
That's
yes.
Using the extension USD can become very handy because if you assemble something and then reference to your .usd, you can internally swap from ASCII to binary and vice versa without changing your higher ups.
That's a good point. Yes.
Yeah.
So yeah. Yeah, good point. Yes. From the practical usage. Yes. So yeah. So we created that. How does it look like? We have default prim world. We have meters per unit. That's centimeters, and we have the up axis y. Yeah, sounds good. We have our kind metadata, right? So it's an assembly. That's what we did, and then we created like our large building F01. This is if you remember. This, right? With the x.02. In the first iteration, we don't have any changes, right? It's nothing. Why is that? It's used in this position, so we gave it a 1, right? In the first iteration, and it creates like this X form. It says the translation to 300 times index -1, which is 0. So 0, 0, and we don't have an offset. 0, 0, 0. Yeah, looks like it. Next, yeah, see, here is 300. Otherwise, it looks equally as well, 600. And now, as we said, at the third iteration, we also have a rotation and a Z offset, right? And it starts again with 0 here that translate because of this modulo operator. It goes to, well, 3, and then if the numbers are larger, it begins at 0 again. Is that too easy for as explanation, or are you all computer scientists? Should I like leave that out?
Please scroll down, because in my experience, the loop goes just to 6. 1 to 7.
Yes. Oh, what did they say? 1 to 6. You're right. You're right.
That's
yes,
Python.
Yes,
Python.
you're right. Yeah. 1 to 6 expression. Yeah, 1 to 7, right. So 1 to 6 is correct. Sure. Good point. So yeah, that's how does it look like? Let's see. USD view again, CD block A. Where is it? Here it is. Where is it? Is it structure? Exercise? No, exercise and it's CD block A. Okay. Yeah. Look at that. So we've got 2 rows, and first row. Let's see, which is the first row? That guy, first row, like, well, yeah, whatever. And if we look, yeah, here's the local transform, nothing, right? 300, 600, 0, but rotated. So here actually, and in Z changed. Yeah, looks good. What do we else have to do? So we look that now the meta-type shows the kind. Yes, let's check for the metadata. Yes, it's an assembly. That's good. Using large building preview, and the metadata shows that the kind field is set to component. Yes. Let's verify. Yes, it's a component. So we have created a valid model hierarchy. Exactly. We have an assembly with 6 components. And as you mentioned correctly, it's going from 1 to 6, which is say the range to 7. Yeah. So I'm creating model hierarchy for essential factors. Keep in mind, operational, shallow, consistent, and extensible. Let's explore each of these aspects in more detail. Operational, shallowness, consistency, extensibility. These things are also good to remember for the certification. What means operational? Component and assembly models should be easily referenced in other contexts. They should include essential dependencies. Yes. So you should basically include everything what you need. May vary by site and pipeline. Yeah, that's what Jan said. It depends how you structure it and what's an operational model. Some pipelines might support geometry-only component models. Yeah, and yeah, that depends. Shallowness. That's that. Shallow monarchy. The kind metadata is explicitly read during composition for all members of the monarchy. So yeah, you want to make it as efficient as possible to get just a structure, in my opinion. And if you have a deep hierarchy, you have like an overhead of composition. Yeah, makes sense. G-prim take this component is a sign that a model hierarchy is deep. Yeah. So if the actual geometry, USD geom seems to be a component, there seems to be in coding we have a code smell. Consistency. So consistent with the ecosystem, crucial, yes. Yeah. So yeah, components should be like fully packaged and renderable. Complex, browse. Consider publishing assets in multiple variations. Yeah. So maybe for pipeline split, you either have the fully packaged thing or just if it goes into other departments, then also parts that can be referenced, right? Extensibility. See, yeah, that's the thing. Having much different road time subcomponents. Yes. As I said, yeah, unintended complexity is the right word, probably. Yeah. Yeah, that's also my experience. So if you want to avoid these extended thing problems, put it in a custom property, schema. And rarely, if ever, I haven't seen it before, expose it to the kind library. So the naming convention, C and A, yeah, makes sense. It's practically a trail for users to easily identify the core kind from an extension. Yes. Yeah. If you do API schemas, they also have to use API as a name component. Yeah. Before we go on to final exercise, consider the following tips. Yes.
As I mentioned before, part of this was covered in the video for the learning for Jesus, my English. Anyway, it was covered in the video, which was shown last Monday from the community guys. And I dropped my little coverage in here in the chat where I took this video and gave it like more insights of what was covered in the video. And you will find this kind and the conflicts in there as well in schemas. So if you want to have another story with it, you can look at this as well.
Great, thank you. So consider the tips. Model hierarchies are structured around the traversal pruning component model boundary. They should be shallow compared to the full prim hierarchy to minimize additional composition costs. Yeah, that makes sense. Model hierarchy should be consistent across different contexts. Yeah, you don't want to get confused. And minimize usage of kind in favor of custom properties or schemas. Yeah, makes sense. So now let's go to the groups. In this exercise, we create the city block, yes, but we'll show the use of the group kind section of buildings in the model hierarchy in the north and south sides of the street. Okay, let's open that. As it's direction exercise, let's do that here. And this guy, exercise 11. Right. Assembly with groups. So Let's quickly go over it. What happens? We have the new thing is this side class, I'd say. We already have our position added side parameters, so it gets a side. What does it do? Yeah, it does this if what we did before, but not on the index, but on the side parameters. Yeah, and it removed the modulus, right? Yeah, makes sense. So rest is pretty much the same. It's the same, yes. So let's copy the code. Okay, it says for the side inside, so for north and south, basically. It does range 1, 2, 3 in this case, then. All right. What does it do? It says we append the child side name, which is basically then left or right. We add this kind to, it's a group. And in this group, we get the path, append the child, append the building with its number, 1, 2, 3, right? And what? Oh yeah, we reference basically our building and do the positioning. Makes sense, right? Any remarks, questions?
Yeah, it's not left, right, but north and south.
Oh, what did I say? North and south. You're right. Yeah, but so better read what there is, north and south. Yeah.
But it's nice that Python can handle it.
Yeah.
Can create a name.
Yeah.
Bye, Jan.
So
yeah, it's explicitly defined as side in the top of the Python file. It's a enumeration.
Yes.
Yeah.
The name and value. Yeah. So let's execute it. Have we saved it? Yes, saved it. So where's it? Hello, command. Did I? No. Strange. Oh, let's do it on the terminal. There we go. Right, assembly with groups. So it created our CD block, I guess. Whoop. Yes. So assembly again, and we have our north group with these 1, 2, 3 elements, and our south group with also 3 elements. Awesome. So let's open it. Well, yeah, actually, I have already opened the thing. Open, and we use as a structure exercise 11 CD block. So, yes, north and south. Awesome. North, south. And is it? It's a group. So nice. Assembly, group, and component. Yes. Awesome. Yeah, that works. So execute. No, there are no visual changes. Yeah, to before, right? But the actual the naming is different, right? So it was from 1 to 6. Now it's 1 to 3, 1 to 3. Was it? I guess. Yeah. Yeah, we did that. See, now we have created like a valid model hierarchy. Looks good. So next exercise, what do we do? Or any remarks, questions for these exercises? I think
maybe just a small remark. It shows again that the whole path is the identifier and not just the prim name.
Yes, yes. Yeah, yeah, good point. If you just had said, put it into building F01, could be this or this. The whole path, world north, building F1, and world south, building F1 is the full identifier. Good point. So variation workstream, what is this? This exercise with limited surfing artists working at the assembly level to make shading variation choices on multiple buildings in city block A. At the shading workstream, allowing surfing to work in the city block context and see how their variation choices are minimum looking into context. Simulate surfing, you create a script that makes random accent color and exterior type choices. These choices will be authored to contain shading sublayer of the city block asset. Okay. So let's look at it. City block A in exercise 12. Open the structure, exercise 12, city block A. So it looks the same basically, right? What do we have to look at? Yeah, got that. Not at the starting state of city block A. All of the buildings have a stucco exterior and a red awning. What's awning? Like this? Probably, huh? Any English speakers? Awning? No? I guess it's that, yeah. No, the starting state of city block A. All the buildings have a stucco exterior and a red, yeah. Set building variations. Open the file. Set building variations.
Markise heißt die
Yes.
Wohnung.
What? Markise.
Markise.
Ah, yeah. Okay. Learned it. Yeah. Markise. So yeah, it's definitely this, I guess. Yeah. Interesting. How can I select this? Yeah. But okay. Let's compare blah, 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 script for randomizing variations. Let's first open the script again. Exercise 12. Set building variations. So what's happening here? With some choices, a working directory. We open the city block and the layer for shading. Okay. Edit context. Okay, interesting. We use an edit context to actually edit the shading layer stage. Okay, and then we copy the code. To do it in this context. So what we do, we traverse the scene. If the prim is a component, oh yeah, if it has variant sets. Okay, so maybe we should also look into the shading layer afterwards. It seems to define shading variants. Does it? Yeah, probably. So we random choice of accent choices. That's our accent choices, right? That's basically colors. And we set the variant selection here. Yes. What are the variant? So we just select one. Okay. Interesting. Yeah. So what happens again? Isn't it? We're traversing through a stage, setting a random variant choice, an accent color for every component asset that has an exterior type variant set. Let's do that and see what happens. Did something. So let's reload the city block A. Exercise, reopen stage. Look at that. Yeah, it changed it. Awesome. So we have some green, blue. Yeah, nice. So what happened? Yeah, we see some variants. Exactly. Rerun the script and yeah, sure, everything changes. Yeah. Well, that's what we did. Let's see. Yeah, let's rerun it. Oh, remember as it looked. Green, blue, reddish. Reload it. Yeah. Reddish, yellow, green. Yeah. Yeah, it's good. How does it look like? Yeah. So by this, we added the sublayer shading, right? Is it shading? Yeah, let's see. Oh, that's good. So this actually introduced these variants, right? Exterior type. And by layering it to the city block, we got this right into our structure, and then we basically what is it? Was it the right one? No. Which one did I miss that? Yeah. We do the shading variants here, right? So yeah.
The variant sets should be defined in the file that is referenced.
Yeah, large building. Yeah, you're right. We override it here. Yes. So let's go to the large building.
So it has to be prepared in the.
There we go. Yeah. See, here we have the variant sets defined in this large building F. See, it says, okay, we have basically an exterior type variant set. It's brick, stucco, basically these two. And also we have this accent color in red, right? That's why it was red in the first place. And in this, so yeah, no, that's really interesting, yeah. So in what happens in city block, actually we have this, right? We reference the buildings. So that's how we assemble like our structure, right? And we override in the shading layer, sublayer, the variant set selection, right? And the color. Shading. And yeah, that's an example for like how things get composed, right? By to the final result. Here we have overwritten the actual variant selection, right? And the accent color. That's pretty neat. And this is how it's composed. Right. This is also here you see at layer stack that it's a lot of layers basically are yeah in the game, right? The composition you see also like you know the city block, shading layer, references, large building, has a payload, right? So and here our variant.
Becomes complex very fast.
Yes, yes.
Mm-hmm. But the shading layer we added via our Python script, the one on the top level, just under world.
Yes. That's by if you I think it was that guy, right?
Yeah, the /content/shading. Yeah.
No.
Where exactly do we map that onto the buildings? Because the buildings have a different path and each of them bring their own shading layer with them, right?
So see, we traverse the stage, so the composed stage, and we check if a prim is a component, and our buildings are the components, right?
Yep.
So it goes like there, checks. So this is an assembly, so no hit basically. This is a group, no hit. This is a component. Ah, yeah, hit. So then it goes and checks. Does a prim has variant sets? Has a variant sets exterior type, which is true, because the building, as we've seen, where is it? This large building. Yeah,
large building,
yeah.
and
see, yes, it has variant sets.
Exactly, and this one is already pre-filled due to the stuff it loads from shading USD. But the shading USD that is here in large building, not the one we are adding in our Python script, right?
So the actual selection is done in the shading USD.
Yeah, in this one, not
No,
the
not
other
in
one.
Not in this one. In this one. In this one.
Ah, okay. Ah, right. It
is
defined in the paths. Yeah. Okay. Now got it. Yeah.
And since we with this edit context, we actually tell that we want to edit now the shading layer, this sublayer.
Yeah. Okay.
Right?
I see. Yep. I just didn't check the shading USD for the paths in there for its overrides. Yeah, makes sense. Okay.
Yeah, and that's quite a neat thing to be able to by selecting like what layer are you working on, but it's also a good method to get confused really quickly.
Yeah.
Yeah. So as they stated, better keep it shallow and yeah, like understandable and consistent. I think consistency is also as you code as well. You have to be consistent and not reinvent something just because it's a little more optimized or something. Yeah, always have the broad picture in mind. Yeah, so I guess we're just through with our model hierarchy. Great. So yeah, next next time, I think we go into data exchange pipelines. Any closing remarks? I guess, yeah. Thanks for your time and have a good weekend.
Yeah. Have a
And
good
then,
Likewise.
weekend.
Yeah, thank you. Thank you.
Bye.
Bye.
Bye.